Alright guys, so I'm going to go through and do some of the problems that maybe we didn't get to in our notebooks, or maybe we did, but I'll just do them again. Like, I'm starting on page 27 and 28, which is where we started graphing. We did have a page before that, but that's not going to be on your test, so it's all good, hopefully. Now, we first started talking about graphing in Vertex Form, which these I actually made a complete separate video about, but maybe as just a quick reminder, if I'm in Vertex Form, I know I am because there's only one x. Your vertex is at 4, -3, and that's because we have a number inside that becomes opposite, and then the outside number stays the same. So I can plot that. I can get another point by doing my slope, which is half, which because it's positive is telling me I'm pointing up. And so from here I would go up half over 1, because I always do my slope as rise over 1. And then my axis of symmetry is right to my vertex at x equals 4. The y-intercept, I could plug in 0 and get it, but like we talked about in class today, as long as you can see your parabola, we have so many questions to get through tomorrow, I feel like let's just get it and go. Okay, so another thing we might want to do is if I'm looking at a graph, I might want to be able to write it in vertex form, which looks like a, parenthesis x minus h squared plus k. Now I can see my vertex, so that's going to go in for h and k, so -2 plus 6. But then I need to consider my slope. And so because they're showing me 1 point away, because 2 and 3 are 1 away, I can just see what my slope is, which is down 3, because it was at 6 and now it's at 3. So down 3 would be my slope. The last one I wouldn't worry too much about, although again, if you want to go back and rewatch this video, you could. On the next one, we talked about graphing in standard form, so hopefully we have all these great notes. If not, there's a picture. I think we filled out most of the things in here, but if we want, we could do another quick one. So for example, if I had y equals 2x squared minus 4x plus 1, I would first find the vertex like we did before, but this time I have to do -b over 2a to get it, and then plug that number in for x to find the y value. So it's not as easy as vertex form. So I would do 4, because double negatives, over 2 times 2, which is going to be 1 overall. And then if I plug that in, I'll have 2 times 1 squared minus 4 times 1 plus 1. So I square the 1 for 1, times 2 is 2, minus 4 plus 1 is going to be -1 overall. So if I was graphing this, I would plot 1, -1, and then I would do my slope, which is 2, only once. So from there, I would go up 1, 2 over 1, and I can flip it over, put it on the other side, because we have that axis of symmetry, and then boom, there's my parabola. Okay? The last way we talked about graphing was in Intercept Form. I feel like I may have done this one with you guys in a video before, but if I'm looking at something like this, maybe this is a little bit trickier, because it doesn't look like Intercept Form, but it is, because I could really write it as x minus 0. And that just tells me that my x-intercepts are 0 and +4, because anything we take out of parentheses should be opposite. So I start off by plotting those as separate points right on the x-axis. Then, to find my vertex, since everything is symmetrical, it's going to be right in the middle, so I kind of just count until I get there, which means that my vertex is somewhere along that axis of symmetry of 2. And so to find it, I just plug it into my equation. So we'd have 2 times 2 times 2 minus 4, which is going to be 2 times 2 times -2 for a -8 overall. So I go down to -8 on my axis of symmetry, and that's where my vertex is going to be. And again, I feel like I can see my parabola, so I could just get it, or I could do my slope, which is up 2 over 1, and then draw my parabola. Okay, so hopefully those are helping. Next we talked about how to start solving, and when we're solving, we're looking for those x-intercepts. And if I'm looking at a graph, hopefully I can just pick them out. But depending on what I'm doing, I probably don't want a graph to solve. Usually, we want to maybe try to factor and solve. So, I think we did all these already, but if I look at the bottom here, something like letter A, I would want to first make this equal to 0. So subtract the 36 and the 32. So I'd have 10x squared minus 76x minus 32 equals 0. I feel like I can definitely take a 2 out here. So I'd have 5x squared minus 38x minus 16. And then I would slide divide bottoms up. So I think what is going to multiply to negative 80 and add to negative 38? So like negative 40 and 2 will get me there. So they'll multiply to a negative 80 and add to a negative 38. So the 2 is just chilling out front. I'd write x minus 40 and then x plus 2. But because I slid the 5 over, I need to divide the 5 out. And I could do the division in the bottoms up. However, since I'm trying to solve, I feel like I can just see my x-intercepts right here. They're just the opposites of those. And so 40 over 5 is really 8. And like not negative 8, because when I take it out, I change the sign. And then my other answer is negative 2 over 5. Now that's a really big number. I probably wouldn't give you something quite that large to factor. But factoring really is our best bet, because it's kind of the easiest way to solve. Now, if I'm solving in vertex form, then I only have one x, and so I'm really just trying to get that x alone. And so we did a couple of those here, example 1 and example 2. But maybe another example like that would be if I had y equals 2 parentheses x plus 3 squared minus 76. I would first replace y with 0, because whenever I'm trying to solve, I need to replace y with 0. And then, because there is only one x, I'm just going to get everything away from it. So I'd first add the 76. Then I would divide the 2. Then I would square root. And then I have to think about, can I square root 38? And nothing comes to mind right off the bat, but maybe I try to birthday cake it a little bit. And I'm like, well, 2 will go into that 19 times. But then 19 is prime. Like, the only number that goes into 19 is 19. And so I can't square root either of those, and so they're just going to stay inside. And so we're going to have plus or minus root 38. X is not alone, but when I subtract the 3, it will be. And I can't really add anything because I never really took the square root. And so those are my 2 answers. Okay, the last way we talked about solving was, and we can go back to complete this if we need to, is using the quadratic formula to do that. Now, I always try to be in factored form like I said, but if I can't, then I'm going to do the quadratic formula. And so let's see if we skipped any in here that we could try. I think we did them all. Yeah. But maybe if we go back to that one that we graphed before, we could try that one. So if I did, for example, y equals 2x squared minus 4x plus 1. Let's say I can't factor that. Or even when I try, yeah, I realize I can't, or maybe I don't want to. So I replace y with 0. Because there is more than one x, I can't just get stuff away. I have to do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if I simplify this now, I'm going to have 4 plus or minus the square root of 16 minus 8 over 4. I'm going to have to like go up a little bit here because 16 minus 8 is going to be 8, and then I need to think about taking the square root of that, which I feel like if I take a 2 out, I can take another 2 out, so I can birthday cake that and take a 2 out. So we'd have 4 plus or minus 2 root 2 over 4. And if you feel like that's not finished because something can divide out in all of those, maybe I divide the 4's for 1, and then plus or minus when I divide 2 and 4, I'm half root 2. And so those are my nasty little answers. Okay. Then we had some imaginary number fun, which we didn't do example 3, so that might be worth doing. So I was looking between the parentheses, and I'm like, okay, what am I supposed to do here? And here I'm supposed to add. So I can add the 4's because they're both real, and I can add the i's because they're both imaginary, and they disappear because negative 3i and positive 3i, 0i. So just 8. Now here I am subtracting, and so I find it easier to distribute the subtraction sign. And then these first parentheses were not really necessary. So once I do that, then I'm just going to combine like terms. And 4 minus 4 is 0. And negative 3i minus 3i is negative 6i. And I will never replace I because it's I, but I will always replace an I squared. So I think that hasn't happened yet, but it's about to. Because here, when I look in between, I notice that I'm multiplying. And so I should really FOIL. So first times first will be 16. Outer will be 12i. Inner will be negative 12i. And last will be negative 9i squared. So for me, I always get rid of the I squared first. I eat that boy out of there, change the sign. I combine my like terms. So 16 and 9 is 25. And 12i minus 12i is 0. And all of your imaginary parts disappeared because these are conjugate pairs. And conjugate pairs will always do that, which is kind of nice. Now for D, I should not distribute an exponent. That's not a thing you're allowed to do. So I wrote it twice, and then I should do FOIL. So when I do first times first, I get 16. When I do outer, I'll get negative 12i. And I'll do inner, I'll get negative 12i. And then when I do last, I get positive 9i squared. So I get rid of the I squared, I make the 9 negative. When I combine the 16 and negative 9, we get 7. And then negative 12 and negative 12 is negative 24i. And I can't go any further because they're not like terms. I can't really, oh, well, maybe this graph here. Okay, so if we go to graphing systems to kind of remind ourselves how to shade and things. So for part B, the first one I know is going to look like a point nut parabola. It's in vertex form because there's only one x. And so I go to negative 3, negative 2 to plot my vertex. And then I do the slope, which is 1. I would make a solid filled in line because it is equal to. And then I'm going to come back to the shading part because I have another thing to graph and consider shading as well. Now this one, because of the bars, I know is a V. Oops, and it should be a pointing down V bars. It has a vertex at negative 3, 4, and then it has a slope of 1, or negative 1, so negative 1 forever in both directions. And we can be linear now because it's a V, not a U. Oop, and it should be solid. Whoopsies, that's easy to fix. Because it's equal to. And then when I consider the shading, for the first one, the parabola, I needed to shade above that line, which is like inside of it. But I also need to stay below the V, which is like under it. So kind of here where I want it to be above the parabola, I can't go past where that V line is. So it's all this stuff right here. So hopefully that's a good reminder The only thing I didn't really talk about was complete the square, but I really feel like something like this